Okay, things are going to get really interesting here. Up until now, we've been using just our front projection map, which means we build our objects, we position them in the scene, we apply a front projection map which locks it into the background, and that pretty much implies that we cannot move our camera around. In fact, if we do move our camera, bad things will happen. For instance, things get really strange. Everything gets out of alignment. If we move it here and we render it, our projections will not match up because the front projection map implies that it's tied to the background image, and we can see things are matching up and our composite is completely blown. Well, that's not entirely true. The front projection map has a new function, well, relatively new. It's been here for a couple of versions of Lightwave, but not many people are using it. In our surface editor, we'll go to the only things we're seeing in our background is our back wall and our ledge. So starting with the ledge, I go in, we have our front projection map. There is something called fixed projection. Now what that does is you apply your front projection map and it like auto sizes it to the background image. And it will auto size it on whichever frame you select. Typically it will be at 0, the very first frame, but you may be moving your camera around using the standard front projection techniques, and then at some point, well, we'll see what happens. We're going to apply fixed projection on frame 0, and we also need to do it with our back wall because they're kind of tied in together. Now what will happen, if I zoom in, look at that. My front projection map is locked onto my geometry. Now, this does not mean you can go flying into Windows. The amount of resolution you have is dependent on as big an image map as you have. And it's going to also fall apart if you go beyond the original image. For instance, if we go too high or too low, let's turn off our anti-aliasing so we can get a fairly quick render. See, we ran out of image right here. You can't do that. However, if you stay within your confines, and a better video card would probably give me a truer representation of my front projection image. By locking in, look how real this looks. It looks real because it's a real image, and I'm getting a certain amount of realistic motion because it's mapped on to geometry that approximates the same shape. Of course, this background doesn't look as good because the front projection map is not appearing as good, and also it's not as true to the actual geometry, which is really just a fence and a lawn behind there. In the scene that is supplied on the CD called Ledged Fix, I've created a camera move that stays within the safe area of my background image. This original image, let's take a look, our ledge image is pretty good size, 2592 by 1944. Our image, our rendered image is 640 by 480. So that is almost, well, 5 times the resolution. So we can zoom in perhaps 1/5 into 1/5 of the image, and it will still hold up at full resolution. And actually, it's a little bit better than that because you can zoom into a digital image a little bit past 1:1, and if you turn on pixel blending, and if it's moving, you can get away with a lot more. Here, for example, I've zoomed in considerably on the background image, and you can see it's starting to break up a little bit here. It's getting a little soft. But if this was clipping right along, you wouldn't even notice it that much. Also notice, look at the reflection in the ball here. It's reflecting to the end of the actual geometry. We got weird stuff going on here. That is because the front projection map in the reflection doesn't quite know what to do. What I might do in that case is just change my ground plane or put in some other object that would be reflected but not necessarily seen by camera. Also notice there's a very slight, we've got some shadowing that's going on from our projection image that we put in earlier where we had our curlicues. We still have the problem with the curlicues being seen through that shadow. Technically that would be blocked, but once again, if this is clipping right along, you would never notice that. I do have a full render that I've put in the background here. This is the render that is on the CD. As we step along here, the camera is moving forward. It's a little blurry there, but that's just because motion blur was turned on. Now this is a pretty good composite, and we're zooming in on these. Look at how the thing is reflected there. This is a pretty successful composite. So take a look at that. We have another example. Here's another instance of using front projection mapping with fixed front projection maps. Now this is the original image. This was a picture taken under the bridge. I like this image because it had very strong geometric lines that I knew would be fairly easy to duplicate. So what I did something a little unusual in that I actually modeled it with the angle. Here it is set, positioned, so it pretty much matches the background image. However, instead of modeling it flat, I kind of model it in the isometric. You can see here, I loaded the image in the background and modeled it with the angle already in. It is really difficult to do. You kind of have to imagine it flat and then turn it in your head. What I had done when I modeled it was put the image in the background, modeled it flat, and then turned it so it was already preset to be in that position. Once I had it modeled, I brought it back into layout, and you can see it's positioned. There's some cheating going on. You know, the wall ends here, matching up with the background. So once the model is in and placed, I applied my front projection map to the geometry. I've also used fixed projection. So let's switch this over to wireframe. Some of it looks okay, like these pillars here looks pretty close, but the walls are just kind of going nuts. I keyframe my camera to kind of move in, and it works pretty well. Now you can only cheat so much when you're using this fixed front projection. For instance, you know, you really feel like you'd be able to go in and look on the other side of that pillar, but it doesn't work that way. In fact, if we render that, you know, it's going to try, but the information just isn't there. It goes up to there. So you can get away with it somewhat, but not very much. So you have to be very careful. But on the other hand, this renders really fast. So it's almost like when you use baking, except instead of baking a new image, you're actually using an existing image and forming the geometry around that. And here's a sample render of that scene with the geometry. I've added some extra geometry, a sphere and a block. The block is a subdivision surfaces object. I've added some texture. My goal was to try to match a texture that you might find in this environment. This has also been rendered using radiosity to illuminate it. This actual background scene, this image that we use for the background, is also used as a light probe image, and that is actually what is illuminating this scene. There is a sample animation on here where you can see the camera moving around using the fixed front projection, radiosity, and it, once again, the modeling took some time just because there's a little bit of detail, but not a terrible amount of time. And if it moves by pretty quickly, it's a pretty successful composite. In fact, showing this to people, they don't instantly see which is the real elements and which are the rendered elements.